We are going to find a state diagram and a state table from a circuit and then find the output sequence as like for the specific input sequence. Okay, so example, find state table and state diagram. Part A, if input x is equal to 0, 1, 1, 0, 0, 1, 0 in this direction, and y1, y2, 0 condition, initial conditions is 1, 1, find the output sequence. Okay, and this is the circuit we are going to solve. We use T flip-flop. And we have two inputs. We have AND gate. We have one input X connected to T2 and the output of T2 connected to AND gate, and Q1 and Q2 are the input of AND gate, and it gives the output, and we have input clock. So it's clock. Okay, so we are going to analyze this circuit and see how does it work. If you have any question, let me know during solving this problem. The first step we need to do in solving this type of instruction is finding the Boolean function of the inputs and outputs. Okay, so we need the functions. We need to find the functions. And before finding the functions, because the outputs are called y, lowercase y, so let's call q1 lowercase y1 and q2 is lowercase y2. Okay, the uppercase y means the next state, lowercase is current state. So lowercase is current state, and capital Y is sorry, yeah, let me just put in lowercase. Okay, y1, y2, and capital is next step. Okay, so we need to find each input output function. So what is the so let's just assign a number for each gate. So gate number 1, gate number 2, the output of gate number 1 of course is x y2. It's x y2. The output of output z is y1 y2, and that's it. And t1 t2 is of course x. Okay, so let's just write them down. So we know that t1 is x y2, t2 is x and Z is Y1, Y2. Okay, so this is the first step. The second step, we need to draw the table and combine those tables. So let's have a table because we have two flip-flops. We have four different combinations. So we write our circuits in this form. X input and Y1, Y2. And this one is for capital Y1. So next state of Y1. We are going to determine the next state of Y1 using the current state of input and Y1 and Y2. Okay? So what we are going to do one more time, we are using this table. We are going to find the next state of Y1 by knowing the current states of Y1, Y2, and X. And of course, we know that the flip-flop is T flip-flop. Y1 flip-flop is T flip-flop. Okay. So, for T flip-flop, we know that if the input is 0, there is no change. If the input is 1, the output will be reversed. Okay? So this one is the like for flip-flop. So let's move and find it. So we say 0, 0, 0, 1, 1, 1, 1, 0. These are the states for Y1, Y2, and X can be 0 and 1. Okay, one by one. We want to find the given uh, pen is T1. So now I have a question. If T1 is T1 is xy2 xy2. Let's see what is the T1 based on the current state of x and y2. So x is 0, y2 is 0. So T1 is definitely equal to 0. So we need to find T1 for all these cells. For all these cells. Is it clear? So for all these cells, we find T1. Why T1? Because we're working with flip-flop 1. Okay, for the next one, X is 1, Y2 is 0, so T1 is 0. For the next one, x2 is 1, y2 is 1, x is 0, so t1 is 0. So let's make it easy. First column, t1 is 0 because x is 0. So no matter what is the value of y2. So because x is 0, for first column, all t1s are 0. So let's look to the second column. For the second column, x is 1. So as long as y1 and y2 is 1, the t1 will be 1. So this one is 1, this one is 1, this one is 0. Any question? No question? So this is the main part, the key part. This is the key part. So if it's clear, you're done. So let's find the values. Okay, the values are easy. For the first row, first column, first row 1, let's call it the row 0 because we start counting from 0. And column 0, T1 is 0, it means no change. No change. No change of Y1. What's the current state of Y1? The current state of Y1 is 0. So no change. So the next state also is 0. Is it clear? So the next state is 0. The next thing for the next thing again, second row is 0. Let's move to second column. In the second column, we not second column, second row. For the second row, first column, T1 is 0, so no change. No change of Y1. Y1 is 0, so it remains 0. Next column, next one, T1 is 1. It means like a complement. Y1 is 0, so it will be complemented to 1. Next one is 1, next one is 0, next one is 1, next one is 1. Any question? No question? Okay. So we got the first table. Let's move to the second table. For the second table, we are going to find the next state of y2. Okay? And we find T1s and T0s for the first color. Okay, so this one is y2. What is T2? T2 is equal to x. T2 is equal to x. We know this. So it's easy. So whatever is x is equal to T2. So for the first column, T2 is equal to 0. For the second column is equal to 1. Why? Because T2 is equal to x. Now for the first column, whatever we have as current state of y2 will be same. So let's look to y2. y2 is this part. So whatever we have here, we copy paste here. So we will have 0, 1, 1, 0. For the second column, everything will be complemented. So we will have 1, 0, 0, 1. Question? Okay, let's move to the next table. So in this circuit, we have two flip-flops and one output. So for each flip-flop, we need one table. For output, we need one table. So in total, we need two tables for this circuit. Okay, so um, the next table is here. And this one is for Z. Z is equal to Y1, Y2. Okay? It doesn't depends to X. Okay? It's not dependent to X. So we can easily implement it. So regardless of X, we AND Y1 and Y2 and put it in this table. Only third row has y1 y2 equal to 1, so third row will be 1 and the rest of the circuit is 0. Questions? Okay, now that we done with this part, it's time to combine all these two tables in a single table. Okay, in a single table. So we build a new table and we combine them. Okay, so we combine, so we get this one, this one, and this one, and we put it here. Okay, and so on. So it is 0, 0, 0. Next one is 0, 1, 0. Next one is 0, 1, 0. Next one is 1, 0, 0. Next one is 1, 1, 1. Next one is 0, 0, 1. Next one is 1, 0, 0. Next one is 1, 1, 0. And this one is milli model. Okay, so we know the milli model, the output depends to each state. So this one we implemented in milli model. And this is the circuit, and now we need to have to assign do a state assignment. So state assignment, we assign A for 0, 0, B for 0, 1, C for 1, 1, and D for 1, 0, and we draw the circuit table. So we say A, B, C, D, and like all zeros from this table, we insert A in this table. Okay, so we assign alphabetic letters for each value. So we will have A0, B0, B0, D0, C1, A1.
Did you happen to say B or D for that for the second
It is
column 1B?
uh, because it
Because
is yeah, because
I
it
thought
is
it was supposed to be
1,
D.
0, 1, 0 is D. So I
Okay,
will
I thought you said B. I'm
no,
sorry.
it's D. Okay, thank you. So the last one is 1, 0 is D 0, and 1, 1 is C 0. So this one is our state table. Any question? So we have a state table. It's time to do our state diagram. Because we have 4 states, we use 4 circles for each state, and we draw the state diagram from state table. So first row, if we are in A and x is 0, we move to A. Okay, so we just complete like this. So we say if input is 0, we stay in the same state A, and the output also is 0. If input is 1, we move to B, and the output is 0. If we are in B, input is 0, the system remains in B, and the output is 0. If it's in B and the input is 1, it moves to D, and the output is 0. If the system is in a state C and x is 0, it remains in a state C and the output is 1. If the x is 1 and the current state is C, it moves to state A and the output is 1. If we are in a state D and the input is 0, it remains in a state D and the output is 0. If the system is in a state D and the input is 1, it goes to state C and the output is 0. So this one is state diagram of this circuit. Any question? Okay. So one thing that was not part of your assignment, but I want to mention here, we know that in Mealy model, the Mealy model, if you define the Mealy model, it says that in Mealy model, the output depends to the input and current state. In Moore model, the output only depends to the state. Okay, and if we look to this circuit, we see that the output is only dependent to the states, not the input. And also, if we look to this table here, we see that the output is only depends to the state. So if we are in a state A, regardless of input, the output is always 0. If we are in a state B, output is always 0. If we are in a state D, output is always 1. If we are in a state D, output is 0. So because the output only depends to it only depends to the state, we can implement this circuit with Moore model in as well as Mealy model. Is it clear? Okay, so if, let's say for example, here if here we had D1, so it was impossible to implement this circuit with Moore model, because we see that in the second row the output depends to the input as well, in addition of the state. But now in this specific example, when we look to the circuit, we see that the output is only dependent to the current state. So so we also have the option to implement it with Moore model. Okay, so let's just implement it with Moore model and have a state table and a state diagram, and so it's useful to see this implementation in Moore model as well. Okay, so let's do that. So we are going to implement this circuit with Moore model. So we need to convert this Mealy model table to Moore model. Okay, in Moore model, the table was something like this. So we have something like this. So it's x01, y1, y2, a, b, c, d, and here we have output. So in Moore model, the output doesn't come like with each cell. For each row, we have uh, one like output. Okay, so let's just copy paste everything from this table. So A, B, the output is 0. B, D, output is 0. C, A, output is 1. D, C, output is 0. So this one is the the Moore model, a state table. Any question? And now we are going to draw the state diagram. So we say A, B, C, D. But this time, because the output, it depends to the input, to the current state, like instead of showing the output in each transaction as a function of input, we show the output of each state inside the circle. Okay, along the circle. So we say A0. So as long as we are in a state A, the output is 0. As long as we are in a state B, output is 0. As long as we are in a state C, the output is 1. And as long as the system is in state D, the output is 0. Okay, I hope that it's clear, and we just draw the circuit, so it's easy. So if x is 0, we move from A to A. So it's just we show 0. We don't show 0 over 0 because the output already is mentioned in the state, inside the state. So this one is like this: 1, 0, 1. Oh, uh, let's just do it like C here and D here. It's better. So if we are in B and the input is 1, we move to D. If we are in C, the input is 0, we stay here. If we are in C, the input is 1, the system goes to A. If we are in D and input is 0, it stays in D. If the system is in D and input is 1, it goes to C. Any question? Okay. Now that we did this part, we are going to find the output as a function of in like input sequence that we have in the problem. Okay. So in order to find the output sequence, we draw the timeline. We draw the timeline like this. And the first line we show the clock cycle, then input X, then the current states, and then the inputs. So because it's T flip-flop, we have T1 and T2. And of course, we need to show output as well. T1 and T2 and Z. If we have a JK flip-flop, instead of T1, we should show J1 and another one K1. Okay, so instead of this, we should have two line J1, K1, and for this one K2, J J2 and K2. Okay, so but because it's T flip-flop, we only have one input. Any question? Okay. Now we draw the clock cycle. Okay, and we use some dashed lines here. Oh, by the way, why I'm adding these dashed lines on the rising edge? When we look to the circuit, when we look to the circuit, we see that these flip-flops are T flip-flop, like are flip-flop and positive edge sensitive. If they were negative edge sensitive, so we should have something like circle. The small C. Do you remember we already discussed in a few weeks ago? So I said that the like falling edge sensitives, they have a circle. So if we had these circles here, So we would use falling edge, but because there is no small circles, it means that these flip-flops, this one and this one, are raising edge sensitive. Okay, raising edge sensitive, and so it's the reason why I'm selecting the rising edge. Is it clear? Okay, so this is the rising edge, and x had a value of 0, 1, 1, 0, 0, 1, 0, and t1 is equal to x y2, and t2 is equal to x, and z is equal to y1 y2. Okay, so this is this one. So we draw the x. So for x we start from 0. So we give a little delay because we already discussed that there is a delay in the signals. So 0, 1, 0, 0, 1, 1, 0. So this one is the input, and the initial conditions of y1 and y2 are 1. So y1 and y2 are 1, and now the first step is finding t1 and t2. T1 and t2. So t1 is x, y2. X is 0, y2 is 1, so t1 is 0. T2, T2 is equal to x. X is 0, so T2 is 0. Output is y1, y2. Y1, y2 both are 1, so output is 1. Okay? Now that we reach to this point, we use this T1 to determine the next state of y1. Because T1 is 0, it means no change in the T flip-flop. So Y1 still remains 1. What about Y2? Y2 is 0. Y2 is 0. It means no change. Sorry, not y2, t2. T2 is 0, it means no change in y2. So y2 is 1. Now that we reach this point, we use these two values to determine t1, t1 and t2. Just back and forth, back and forth. For one clock we use y1, y2 determine t1, t2. For the next clock we use t1, t2 to find y1, y2. So because y1 is 1 and x is 1, because y1 is 1 and x is 1, t1 will be changed to 1. T1 changes to 1. Because y2 is 1 and x is 1, t2 also, which is equal to x, changes to 1. So this one is the next step. What about z? Z is y1, y2. Both are 1, still z is 1. Now that we reach to this point, we again use this one and this one to determine y's. Okay? So we say t1 is 1, it means that y1 should be complement. So y1 is 0. And t2 is 1, it means that y2 should be 0. Now that we reach to this point, again we use these values to determine y1 and y2. And like back and forth, we continue until the end. Is it clear? Okay, so if we draw this like this circuit, y1, we will have 1, 2, 3, 4 zeros, and this one will be y1, y2 will be this one, t1 will be this form, and t2 will be in this form, and z will be this form. So if we want to write the z, we should say z is equal to 0, 0, 0, 0, 1, 1, in this way. Okay, so this one is the okay. Any question? Okay, so this was the solution of one of the problems.